Okay, so in this video we're going to be having a look at sigma notation, which is on the A-level math specification. We're going to be looking at some of the rules for sigma notation and tricks that can help you simplify the question, and then we're going to be having a look at some exam questions. So, if we have the summation of A, where A is just a constant, from R equals 1 to N, what we're saying is we are adding A plus A plus A all the way to A, which is the nth time that we do that. We're doing that n times, because n is our top counter. So we're saying A plus A plus A n times. So what that means is that's actually n times A. So this summation here is equal to n times A, where A is a constant. So if we have the summation of, let's say, 2, from R equals 1 to 10, we could say that's 2 plus 2 plus 2 plus 2 10 times, which we can then say is 10 times 2, which is just 20. If we have the summation of A times R, where we're going from 1 to N, we can say that we are able to bring that A out of our summation, as that's just a constant. So what that's equal to is A lots of the summation of R from R equals 1 to N. And we're going to multiply that by A. So for example, if we have the summation of R equals 1 to 5 of 3R, that's the same as 3 lots of the summation from R equals 1 to 5 of R. And we can write that as 3 times R as 1 into there, and we will get 1. We can put R as 2 into there and get 2. We can put R as 3, we can put R as 4, and then we're going to stop at R equals 5. Adding all those together, we'll get 5 plus 5 is 10, plus 4 plus 1 is 15. So that gives us 3 times 15, and 3 times 15 gives us 45. Now let's say we had an arithmetic sequence, and we had the summation of R equals 1 to N of, let's say, R. What we're doing is we're starting at 1 and we're going all the way to N. So we're putting R in as 1, so we're doing 1. Then we're putting R in as 2, so 2, then 3, then 4. And we're doing that N times. So what that means is we're forming an arithmetic sequence as we're going up by the same amount each time. We're going up by 1. So if we know that we're summing this sequence and it's an arithmetic sequence, we can use the formula Sn is equal to n over 2 times A plus L, where L is the last term and A is the first term. And n is just the number of terms that we've got. So we know we've got n terms because we're going up to n. So Sn is going to be, well, our n's just going to stay as n over 2. Our first term in this sequence is just 1. So we can write A as 1. And the last term is just n. We're doing it n times, so plus n. And simplifying that, Sn is equal to n times n plus 1 over 2. And that is a generic result that you need to know. When you are summing a sequence and it's just R or it's just A, whatever your counter is here, you're starting at 1 all the way to n of R, you can use this formula here to find the result. Now let's have a look at splitting sequences up. So let's say we had the summation of AR plus B, where we're starting at 1 and we're going to N. What we're doing is we're putting R as 1 in, R as 2, R as 3. So let's form a little bit of the sequence. We're going to put R as 1 in to give us A plus B, then R as 2 in to give us 2A plus B, and so on, giving us 3A plus B, all the way up to NA plus B. Now if we were just to sort of collect the a's together and collect the b's together, we can take a factor of a out and we'll have 1 plus 2 plus 3 plus all the way to n plus b plus b plus b, and we're doing that n times. So how else can we write that? Well, using the information that we just learned, this we can write as this formula. And that formula in sigma notation can be written like this. So we're going to write 1 plus 2 plus 3 plus all the way up to n multiplied by a times a lots of the summation of r, where r is starting at 1 and ending at n. And we're adding here b n times, so we can add on nb. And that's another generic result that we can use. So we can split the sequence up and make it a little bit easier for us to use if necessary. We can bring the a out to the front because it's just a constant, and we're doing 1 plus 2 plus 3 n times, so that's where we get this part of the sequence from. And then we're adding b to it n times, so n times b. In an exam, you may be asked to write sequences in sigma notation. So for example, let's say we had 8 plus 7 plus 6 plus 5 plus 4. And we're asked to write that sequence in sigma notation. The first thing we need to do for any sequence when we're asked to write it in sigma notation is work out the nth term. So if we have a look what the term-to-term rule is, we're going down by 1 each time. So it's going to be minus n. And then to get from minus 1 to 8, we need to add 9. So the nth term, writing that in a neater way, is 9 minus n. So we know that we're going to have the nth term, so that's what's going to follow our sigma signs. We've got the summation of 9 minus n, and we're going from n equals 1. This time we're not using r, we're using n, that's fine, it's just a different variable. All the way to, well, how many terms have we got in the sequence? We've got 5. So 5. And that's how we write the sequence in sigma notation. And it works for any sequence. Work out the nth term and have a look at where you're starting and go up to your top counter. Now we need to look at when we have the bottom counter and it's not equal to 1. So let's say we have the summation of 5r from r equals 5 to 10. What we're saying is we've got this sequence and we're adding all of the terms together, starting from the 5th term to the 10th term. What we have to do is we have to split this sequence up and have 2 sigmas, both starting from 1. So what I'm going to do is I'm going to generate a little bit of this sequence starting from r equals 1. So it's just a 5 times table. So it's going to be 5, 10, 15, 20, 25, 30, 35, 40, 45, and then stopping at 50 as we want our top counter to be 10. So what this summation means is starting from the 5th term, we want to add the 5th term all the way up to the 10th term and add them together. So we want to add this term, this term, this term, this term, this term, and this term, and we want to add them together. So what we have to do is we have to split this sequence up into 2 sort of separate, 2 separate counters, if you like. So this sequence becomes the summation of 5r from r equals 1, so we want to create the r equals 1, to 10. So we're adding all of these together, including these. But we don't want those 4 circled, so then we have to take away the summation of 5r from r equals 1 to 4. We do 1 less than the counter we had here. Because we add all of them together, then we take away the summation of the bits that are less that we don't want, the circled ones there. So putting that into a formula, if we have the summation, and we'll just call it of r, and if r equals x, where x is not 1, and we're summing that all the way to n, we can write that as the summation of r equals 1 to n of r minus the summation of r from r equals 1 to x minus 1. We do one less than the x here because, as we looked in the demonstration above, we don't want these four that have been circled, so we need to take them away. So that is another generic formula or result that you need to know. Okay, so now let's have a look at some exam style questions. This question says evaluate the summation of 7 minus 2r from r equals 1 to 20. Now we've got an arithmetic sequence, as the nth term here is arithmetic. So we can use the formula Sn is equal to n over 2 times a plus l. And we can find the first term by substituting r as 1 and finding the last term by substituting r as 20. So we know that n is going to be 20 as we're going to have 20 terms. And our first term is when we put r as 1 in, so the first term is going to be 5. And to work out the last term, we can put r as 20 in to give us 7 minus 2 times 20, which is 7 minus 40, which is minus 33. So then we can say s of 20 is going to be 20 over 2 times 5 plus minus 33, which is minus 33. And when you put that in your calculator, you get negative 280. And that is your final answer. Looking at part B, this time we're summing a geometric sequence. So we're going to be using the formula Sn is equal to a over 1 minus r to the n divided by 1 minus r. And we're summing from r equals 1 to r equals 10. So we want the first term, which is just going to be 3 times 4. We could say n is 10 first, then we can say a is going to be 3 times 4, which is 12. And our r value that we need to calculate is the ratio to go from the first term to the second term to the second term to the third term. And we're multiplying by 1 more 4 each time. So we're multiplying the first one by 1 lots of 4, then the second time by 4 times 4. Okay? So we can see that the ratio is multiply by 4. So if we've got s of 10, that's going to be a, which is 12, and we're multiplying that by 1 minus 4 to the 10. It doesn't matter, we could have used the other formula, which is Rn minus 1 over r minus 1, but it doesn't matter, it still works out the same, divided by 1 minus r, which is 1 minus 4. So s of 10, once you put that in your calculator, you get 4,194,300 as your final answer. Looking at the next question, we want the summation of 5r minus a half from r equals 9 to r equals 30. Now there's two ways that you can actually do this. You can split up using the information that we previously learned, where we want to split up so that both counters start at 1. Or we can say we're going from r equals 9, so the 9th term, to the 30th term. What we want to do is work out how many terms we're actually adding together. So to do that, for part A, we can say 30 minus 9, which is 21. And then we need to add 1 back on to get 22 terms, so we can count the 9th term here. So we want to do s of 22. So what that means is we've got an arithmetic sequence. We're going to be using the formula n over 2 times a plus l, where n is 22. The first term is when we put r as 9 into that. And when we do that, we get 5 times 9 minus a half, which is 44.5. And the last term is when we put 30 in, and that will give us 149.5. So doing the sum of the 22 terms, that's 22 divided by 2 times 44.5 plus 195.5, and when you put that in your calculator, you get 2,134, and that is your final answer. Now again, if we look at the method we just learnt, the summation of 5r minus a half from r equals 9 to 30, we can split that up and we can say that's the summation of r equals 1 to 30 of 5r minus a half, minus the summation of 5r minus a half from r equals 1 to 1 less than this, so to 8. And then we can work that out by using two different formulas. So we can say, it's the Bose arithmetic, so we're going to get n over 2 times the first term, which is 4.5, plus the last term, which we just worked out was 149.5, minus, and we'll put that in big brackets there, minus, and we're going to have n, which is 8 over 2, times the first term, which is again 4.5, plus the last term, which is when we put 8 into there, which gives us 39.5. And again, when you put that in your calculator, you do get 2,134, which is the same answer that we got there. So either way works. Looking at part B, we can do both of the same things, but I think it's much simpler or quicker just to have a look about the plus 1. So if we have a look at how many terms we've got, 200 minus 100 gives us 100, but that doesn't count the first 100th term, so we need to add one back on. So we're going to be doing s of 101. And this time we've still got an arithmetic sequence, so putting our values in, we can say n is going to be 101, as we needed to add one back on, because we've just worked that out. We need a value for a, so the first term, which is going to be 304. And the last term is going to be 3 times 200, which is 600, plus 4 is 604. So it's going to be n over 2, 101 over 2, multiplied by 304 plus 604. And when you put that in on your calculator, you get 45,854. And that's your final answer. You could have again used the splitting the summation up to get the counters as 1 on the bottom and done the same thing, but I think it's much quicker to do the question like that. Question 7 says, show that the summation of 2r from 1 to n minus the summation of 2r minus 1 from 1 to n is equal to n. So, if we have a look at this sequence here, we're able to pull that 2 out to the front. And then that becomes 2 lots of the summation of r from r equals 1 to n, as the 2 is just a constant, so we can bring that out. Using the information that we learned previously, this can become 2 lots of n times n plus 1 over 2, as it's just an arithmetic sequence. It's 1 plus 2 plus 3 plus 4 n times, so using the formula, that's what we get. And then we're minusing, looking at this term, we can split that sequence up. And again, we can bring the 2 out to the front. That's r from r equals 1 to n, and now we've just got r, minus the summation of 1 from r equals 1 to n. And now we can simplify this up, and this up again. We can say that's 2 lots of this summation, so that becomes n times n plus 1 over 2, minus n, because we're adding 1 n times. Right, putting whole brackets around that, because we want to minus all of that. Simplifying this, we get n times n plus 1, minus, cancelling the 2's, n times n plus 1, and a minus makes a plus n. That cancels just to leave n on its own. And that's what we were asked to show in the question, that the summation equals n. Question 9 says find the value of the summation of 200 times a quarter to the power of r, starting at 10 to infinity. So again, there's 2 ways to answer this question. We can use the sum to infinity formula, which is a over 1 minus r, and we're starting at the 10th term, so our a value is going to be 200 times a quarter to the power of 10. And our r value is going to be a quarter, so we're increasing the number of times we multiply by a quarter on each term. So that's going to be sum to infinity of a, which is 200 times a quarter to the power of 10, divided by 1 minus r, so that's going to be 1 minus a quarter, which is 3 quarters. And when we do that, we get the sum of infinity is 25 divided by 98,304. Or, like in the previous example, we could have split the summation up so we get the bottom counter as 1 and worked from there. Question 11 says, given that the summation of 2 times 3 to the r from r equals 1 to k is equal to 59,046, show that k is equal to log of 19,683 divided by log of 3. So we're starting with a geometric sequence. As we can see, it's 2 times 3 to the power of r. So the variable in our sequence is in the power. So we've got a geometric sequence. So we can use the formula Sn is equal to a times 1 minus r to the n over 1 minus r. And we know that our n value, what we're summing to, is k. So S of k we can put in is going to be this value here. So we can say that our first term is going to be when we put 1 in, which is going to be 6, because 2 times 3 to the 1 is 6. And our ratio that we're going up by each time is going to be 3. As we're timesing by 1 more 3 each time that we increase our number of terms. So what we can say is, putting the information into that formula, is S of k is going to be a, which is 6. And I'm going to flip the formula round because our r value is greater than 1. So that's going to be 3 to the k minus 1 divided by 3 minus 1. So S of k is going to be 3 minus 1 is 2. So 6 divided by 2 is going to be 3 lots of 3 to the k minus 1. Now we can say that that is equal to what we're told in the question, the summation here. So it's going to be 3 times 3 to the k minus 1 is equal to 59,064. So dividing both sides by 3, that's going to give us 19,682. And now we want to do is just solve for k. So adding 1 to both sides, 3k is equal to 19,683. And if we take logs of both sides, log of 3k is going to be equal to log of 19,683. Bringing that k down to the front, we can say k log of 3 is equal to log of 19,683. And then dividing by the log of 3, we can say k is log of 19,683 divided by log of 3. And we've got that as required in the question. Part B says, for this value of k, calculate the summation of 2 times 3 to the r, starting at k plus 1, working to 13. So we need to work out the value of r. So r equals k plus 1. So r is going to be log of 19,683 divided by log of 3 plus 1. And when you put that in your calculator, you get 10. So we know that our lower counter is going to be 10. So what we're actually doing is the summation of 2 times 3 to the r of r equals 10, starting at r equals 10 to 13. And we've got a geometric sequence, so we need to work out our Sn is equal to a times 1 minus r to the n divided by 1 minus r. And we can say that the number of terms that we've got is 4 terms, including the 10 terms. We want the 10th term plus the 12th, the 11th plus the 12th plus the 13th. So we're going to have n equals 4. The first term is when we're going to put 10r as 10 in, so 2 times 3 to the 10, which is 118,098. And our r value is going to be 3. So S of 4 is going to be 118,098 multiplied by flipping the equation round as we want our r value first because r is greater than 1. 3 to the n, which is 4, minus 1 divided by 3 minus 1. And putting that in your calculator, you get 4,723,920 as your final answer. And again, for part B, you could have also split the summation up into 2 summations that start at the counter of 1 and then done 1 less, or you could have had a look and see how many terms you've got and added 1 on. So hopefully now you understand a little bit more about sigma notation.